So, Pat, before we get into your background, I want to start with a specific story. Tell me about a project where everyone did their job right and it still went sideways.
Sure. We had a situation where it was the first time working with a customer, and they came to us for a design. And with the best intentions, we both thought it would be advantageous to leave the requirements a little bit loose on the front end. From their perspective, they were telling us our ultimate need is really about the power output at the antenna. So you guys can be a little bit loose with maybe the input and how the situation works inside the amplifier. And our intention was, let us have a little bit of design flexibility, but we'll leave headroom for the power output so that ultimately we can give the customer what they need on the back end. And ultimately what happened was 4 iterations of the same piece of design hardware, and everyone paid a price in schedule as well as budget.
So, walk me through, what did both sides think they were agreeing to?
The customer thought they were giving us a little bit of design freedom with the goal in mind that ultimately, if we need a little bit more power on the back end at the antenna, Triad will have designed this such that we've got some headroom. So let's not worry so much about the details of how the inner workings go on, as long as the intention is known to have some flexibility on the output.
And I know you mentioned that in the end, both in money and timeline, you both paid for it, but how did that affect your relationship between you and the customer?
It's a tough one. Ultimately, we still have a strong relationship with that customer, but what it does is it not only affects time and budget, but it affects the trust. Right now, you're overthinking every conversation you're having, every spec that you write, every email. Am I being detailed enough now? So it really gets at that root thing that everything's built on, which is the trust between the two design teams.
As you look back on that, what should have happened? If you could go back to the start of that program, what would a good spec have looked like?
A good spec needs that work put in up front. It needs to be detailed, and it needs to really state what the unit ultimately has to do. Because if you think about the design process after the spec is complete, what is ultimately translated to a design engineer is a specification, not the intention, not the discussions that went in. It's really the spec. So the intention is to have headroom, but that's not written in the spec. You have this whisper down the lane thing that happens where an engineer's job is to, by design, by intention, not to have headroom in a design. It's to do the job that the spec states as efficiently as possible. So things like headroom or the intention to have a little bit of wiggle room at the end, they don't translate.
Most engineers on the customer side have never been inside a supplier's design process. You do this all the time. So walk us through what actually happens when a loose spec comes in. What do payload engineers leave loose most often? And what does the hardware look like when they do that?
I'll give you the example that's near and dear to my heart because we see it quite a bit. The perfect example would be the RF drive input level to, let's say, a basic amplifier. So we're asking the customer, what level would you like to input to the amplifier that will give us the cleanest signal possible? And so a customer will say something like, we would prefer to give you 5 dBm, but the exciter is linear up to 10 dBm. So now if I make the classic mistake of writing 10 dBm as the drive level input, the design engineer, that's what gets to the design engineer. He's going to say, okay, I have 10 dBm to work with. Oh, geez, I can eliminate an entire drive stage, an entire gain stage of this amplifier. That's going to lower the price. That's going to be less work, so I can shorten the timeline. And we're going to save money because we're not putting these parts on the board. And so he's absolutely doing his job to the best of his ability, and he's doing the right thing. He's designing to the spec. Then you get the end product, and you find that maybe we're not meeting the spectral mask requirement. The output's a bit noisy. And you root cause that back, and you find out that, well, the exciter is twice as noisy at 10 dBm than it is at 5 dBm. So you go to the design engineer and you say, hey, we need a cleaner input. We've got to use 5 dBm as our drive level. And you see his eyes go wide and he says, I designed for 10 dBm. I eliminated a gain stage because the spec told me I could. So now you're redesigning a board, you're respinning it, you're going back to manufacturer. It's a big penalty paid in the schedule.
So Is there any sort of guidance or rule that you give customers early in a program like this to help them avoid that very thing?
We like to say you have to earn your wiggle room. You have to earn your headroom. So work the spec on the beginning. Make sure it is tight. Make sure it meets what the program needs it to do. There is ample opportunity to put headroom, to work on wiggle room once the product is developed and overperforming. But you've got to earn that. You cannot write that into the spec.
So, Pat, you said customers often don't know what they don't know. You do this all the time, and for many, this could be the first time that they're doing this. So what does that actually look like when someone first comes to Triad?
Sure. We had a customer come to us and they had nothing but a goal in mind. We want to put a satellite constellation up to provide a particular type of coverage to a particular area, but no power requirements, no technical specification, just a goal in mind. And typically the immediate response that you're going to get as a company like Triad is to say, you guys really have to tighten up your technical team. You've got to be able to write a spec. You have to give us something we can quote to. We didn't take that approach. We worked with the customer and we wrote the technical specification for them. And what we found out was that they knew a tremendous amount about that market, that emerging market, and how their system needed to work, but they just didn't have the ability to translate that into a technical specification. So by going the extra mile and working with that customer, we were able to translate that into a technical specification, which they ultimately then took and bid against us on the open market, but that's a different story. But that was one example that comes to mind.
What did Triad get out of that engagement? What did you learn?
The thing that Triad got out of it was an amazing understanding of this emerging market, which we previously didn't know. We knew about it. The level of which we understand it now is vastly superior to when we started. So Triad gained an immense amount of market knowledge, the competitive landscape, and just how an emerging market was coming. And that allowed us to be on top of that, to be out in front. Instead of bidding to specifications, we were able to talk high level, highly technical detailed on specifications with not only this customer, but others. And that customer relationship has lasted till today.
So tell me about a time where the gap wasn't in the spec. It was in the integration, where a detail that seemed really minor turned into a real problem.
Sure. We had a particular customer come to us, as they often do, very tight schedule. We need this yesterday. We had a product that was very close to meeting their need. And through the technical discussion, the uncovering process, we brought up mechanical integration. We told them that this particular unit came as a circuit card, not in a housing. What were they going to do for mechanical integration? Excuse me. Did they need us to design a mechanical housing for this unit? And the quick answer was, no, we don't have time for that. We've got that covered. That's on us. And so jotted that down. Mechanical integrations on the customer. That was all good and well. We delivered the products. They worked great throughout the test process. They launched the spacecraft and things were still working fine until they were not. And we got a call one night that we had redundant failures of our units. We had redundant units and they had both failed. Ultimately, we traced that problem back to the power generation system. It was nothing to do with the design. Throughout that conversation, we asked about the mechanical integration. We said, what are you doing? How are these housed? How are you protecting them? And what we found is they had essentially draped the equivalent of a space blanket over these units and bolted them directly to the platform. So no housing protection, no aluminum between our circuitry and the elements. They just left that detail to the last minute, and it was a very underwhelming solution. So that is an example where you really need to make sure you cross every T and dot every I, and you can't force a customer to accept your help, but you can sure ask more than one time.
So what is the lesson from both of these situations?
It's your job as the bidder on this program to find the gaps between what's written in the technical specification and the end solution. You've got to go the extra mile and really dig into those details to make sure nothing is left untouched.
So I'll take that one step further because I know a little bit about you and I know a little bit about Triad, and I know you guys go the extra mile and you do the extra work. And sometimes the customer doesn't always know what they need to know. So how would you explain that to someone who hasn't worked with Triad before?
It's about a partnership. You've got to be able to trust the folks that you're working with. Are they asking the questions that you're thinking about? If all they're doing is going over the details of a spreadsheet with your technical requirements in there, and they're not asking you about the intention behind every technical specification, there's a story of what the project or what the mission needs to accomplish. And if they're not asking about the larger picture, and they're not thinking about the intention behind the requirements, you've got a partner, maybe you don't have a partner, maybe you have a supplier, and that's the difference between a partner and a supplier.
You've talked about the value of flight heritage. For an engineer who hasn't worked with a space qualified supplier before, why is that important? What does that mean?
Flight heritage is so vastly important, especially in the new space industry, because it's essentially what you can hang your hat on. As you mentioned, if I was a design engineer that hadn't done this before in this market, the types of questions I would be asking is this unit, first of all, the best case scenario would be, does this unit have flight heritage? If it doesn't, if it's a new design, it's not going to happen every time that you can just buy something off the shelf with flight heritage. Then the question comes to, what parts of this design are based on units that do have flight heritage? Flight heritage means you've gone through this rigorous process of design, of test, of verification, and you've launched these things into orbit and they're operating the way that they should. And the level of confidence that comes with that is, it gives everyone the warm and fuzzy that they're after when going into a new design, is that, hey, 85% of this thing is built on the back of something that has been proven in space. So I know that the 15% we need to change, that's what we really need to focus on. The rest, I can sleep well knowing that these units have already been operating in orbit.
So tell me about the customer who launched 19 units that were never designed for space.
We had a customer call us and say, hey, we'd like to buy 10 more of this particular unit. And the customer was very well known in the space industry. And the unit they were asking for was not designed for space. It was a terrestrial amplifier, and the alarm bells went off, and we immediately asked for a call. We were very upfront that the unit that they were interested in was not designed for operation in space. And the answer they ultimately came back with was, well, the first 19 that we bought, we launched and they worked great in space. So we'd like some more of those, please. And the design engineer's jaw just about dropped through the floor when he heard that, because he designed that unit. He knew that there was this large bank of electrolytic capacitors, which are known not to operate well in space at the temperatures required and to outgas. And so the only thing he could think was that by luck, these units were hermetically sealed at the factory, and that's why it worked. But that was a story where we were all gobsmacked. They ended up using a third-party purchaser to buy those units in the first place. Otherwise, we would have caught it then. So we worked with the customer. They gave us a little bit of time. They gave us a few months to redesign the unit, to get the parts that were possibly questionable for use in space out of the design. And we delivered new units that were designed to an even higher level of rigor.
So I know Triad, and you in particular, know what questions to ask of an RF engineer. But what if someone's not doing business with Triad? What sorts of questions should an RF engineer be asking when they're evaluating whether a product is actually suitable for their mission environment?
Some of the questions that a design engineer should ask is, first and foremost, flight heritage. Have the units that we're purchasing flown prior, or are they based on units that have flown previously? And it's not about the questions necessarily that are being asked, but you have to listen to the answers that your supplier partner is giving you. It's the type of answers. Are they asking questions back to you about the intention of the requirements, about the intention of the mission, about the concept of operations for a mission? Again, if your supplier is just down in the weeds of the technical requirements, don't get me wrong, requirements are important, but it's about more than requirements. It's about, is this partner asking questions that I'm asking myself about the mission? Are they asking about the story? Are they asking about the intention of the mission requirements and what this platform really needs to do in space?
So, Pat, we jumped right into this conversation, and I'd like to just take a step back and give people some context on your background. You didn't start in space. Tell us a little bit about your career.
Sure. No, I'm relatively new to space. Relatively speaking, started as an electrical engineer at a large defense contractor. I was a young go-getter. I was always asking for work. And to shut me up, one of the things they did is they locked me in a room with what they called the dog pile of broken circuit boards. There was hundreds of broken circuit boards, and they just said, here, fix these, do what you can. And through that exercise of months of debugging, found out a few things. I learned, first of all, I'm not a great circuit board designer. I saw the level of detail that went into designing circuit boards and realized that is not where I bring the most value. I'm better at breaking things than I am at fixing or at designing things. I'm better at breaking and fixing than I am designing. I also found out that it's not a one-man show. I needed the help of assemblers, of production employees, of so many people. As a young engineer, you find a problem and you think, everyone get out of my way, everyone replace this part because I determined this part is bad. And let's prove that I found out what was wrong and that we can fix this board. And then you realize there's a reality in a factory. There are production schedules. There are employees that need vacations. There are people with skill sets that you will never have. And you need all of them. You're going to depend on all of those people. And that's really where I learned that you've got to build trust with others, that you've got to work within the bounds of what they're capable of. You've got to use their capabilities that you don't have to fix this problem. And as I developed those skills, I think I built trust with the people I work with, and that led them to start putting me in front of customers. And I always joke that once they found an engineer that could hold a conversation, was never non-customer facing from that point forward. And I ended up in a solutions engineering role, which is customer facing front end. This is before you've won the contract. So there's a real level of trust that your company has in you that we are going to put you in front of customers to prove to them that we can do the job. And so then your job is to, again, understand the customer's intention, the concept of operations, what their mission is, and how to use the products that your company builds at the heart of that design to accomplish those mission requirements. So you're not only building trust in your own company that they're willing to put you in front of the customer, but then your job is to build trust with that customer and prove to them that your company can do the job they need you to do.
So if I were to ask you just to succinctly say, what did being a pre-sales engineer in front of a customer teach you that a pure design engineer who's never interacted with customers, what's the biggest difference there?
I've seen it happen in real life where I was working an integration job and I was on a first name basis. I was close with the customer, and the design engineers don't have that level of connectivity with the customer. And I was able to bring one of the design engineers to the site, to the job site, where they, for the first time, saw that people in a particular Navy were using the products that they built as part of their day job every single day, that the products they were building, the software that they were developing was being used by people every day as part of their jobs. And I saw an immediate change in attitude. Connecting the design engineers with the people that are using their products, there's really nothing stronger than to make that connection and to see the change in attitude of a design engineer, to realize people are using these products I'm developing to do their job. I've got to make sure this stuff works. I've got to make sure that the little annoyances aren't there, that they don't have to click 3 times to do something that they're doing 5 times a day. I have to make that more obvious. I have to make the product more intuitive, and I've got to make sure that it does the job they need it to do, and to go into every design exercise with that in mind.
So if an RF engineer is sitting down right now to spec out a payload amplifier, what is the one conversation they should be having before they lock anything down?
There's a story behind every technical specification. There is a reason that this product is being built, and there's a job that it has to do. And so the first question you have to ask yourself is, are the requirements I've written accomplishing the mission that this product has to do? And then to follow that on, are the people I'm working with coming from the same perspective? Are the people that I'm sending this specification out to quote, are they thinking about it from the same mindset? Do I know the engineers that are doing the design, or am I being held at arm's length between myself, who's writing the requirements, and the design engineer that's going to lay this circuit out on a circuit board? Or is that communication open and honest, and I can have that conversation about design trade-offs? So it's about mindset. It's, am I writing requirements that meet the mission? And are the folks that I'm going out to bid this job thinking in the same mindset that I am.
Okay, last question. What is the one thing you wish every payload engineer knew before they came to you?
The attitude that's required to do a design, right? We work in a small industry, believe it or not. Satellite design is a small industry, and you have to go in. I think we all want to do this for the rest of our careers, and you have to approach every task with that in mind. Am I going to be proud of the outcome of, did I put in the work so that the product that ends up coming out of this design process, am I going to be proud of that outcome? And am I working with partners that come from that same mindset? Are they going to be proud about the product that ends up being produced because of the work that we're doing now?